Hi guys, welcome. We're going to be working on the short response for the June 2015 exam, and if you're following along in the workbooks, it can be started on page 52. I'm going to be using the different version of the exam, just one that gives me a little bit more space to work, but they're the same questions, so you might need to grab a piece of paper to be able to follow along. All right, so starting with 28, this is a 2-point question. We're going to solve algebraically for x. So when I look at this equation, I notice that I have a base of 5 and a base of 125. In order to solve an equation like this, I need to get like bases, like the song, it's all about the base, So I'm going to keep the 5 raised to the 4x, and I'm going to rewrite 125 as 5 to the third, because 5 to the third has the same value as 125, and I'm going to keep the exponent of x minus 1. So now that the bases are the same, I kind of ignore them for a moment, and I'm going to concentrate on the exponents. So we have 4x equals, now I need this exponent of 3, and the x minus 1. So the most common mistake here would be that we wouldn't distribute the 3 to the x minus 1, so don't make that mistake. I'm going to solve for x by subtracting 3x to both sides, and I get x equals -3. So a nice little 2-point question, and you just have to remember it's all about the base. In triangle ABC, determine the number of distinct triangles that can be formed if the measure of angle A is 85, side A is 8, and side C equals 2. Justify your answer. So this part right here, distinct triangles, whenever you read that, I want you to say that's law of sines. So we're going to draw a diagram. Again, you don't have to draw the diagram. I happen to like drawing the diagrams. I like the visual representation. So this is 85 degrees. Side A, which is across from angle A, is 8. Side C is 2. So I'm going to go ahead and I'm going to find the measurement of angle C. I'm going to use the law of sines to do this. So we're going to say the sine of 85 over side A equals the sine of C, which I'm solving for, over 2. We have to cross multiply here. So 8 times the sine of C equals 2 times the sine of 85. One of the biggest mistakes is that students will write 2 on this side, and then when they type it in their calculator, they forget to do the parenthesis, and it just makes things complicated. So don't do that. Divide both sides by 8. We get sine of C equals... All right, so I'm just going to grab my calculator here. I'm going to type in an alpha y equals 2 sine of 85 divided by 8, and I'm just going to hit the mode button to make sure I'm good. I'm in degree mode, and hit enter. So I get a crazy decimal. Now in order to turn that decimal into a degree measurement, I'm going to hit second sine, go up and grab this. And the measurement of C is, so the nearest degree is 14 degrees. So C equals 14 degrees. So they wanted to know how many triangles could be formed. Well, the measurements possible for the first triangle would be 85 degrees. Then I'd have that 14 degrees that I just found. The measurement of angle B, well, 85 plus 14, take that value, subtract it from 180 degrees, and you get 81. So one triangle is going to have these measurements. Well, let's see if we can get another triangle. Again, we always have this 85 degrees. Now we're going to go ahead and find this one. This one is supplementary to the angle we found. So that means that the 14 degree and this angle that I'm going to write in here have to add up to 180 degrees. So to find this one, I do 180 degrees, take away 14, I get 166 degrees. And if you notice, 85 plus 166 is over 180 degrees. So it is not possible to get a third angle. Actually, these two angles can't even form a triangle because they are over 180 degrees. So the answer to this question would be one triangle. The probability that Kay and Joseph Dowling will have a redhead child is 1 out of 4. If the Dowlings plan to have 3 children, what is the exact probability that only one child will have red hair? Well, let's see. The probability of red hair is 1 out of 4. So that means the probability of not red hair would be 3 out of 4, because if you remember, these values have to sum up to 1. So we're going to have 4 children, and we only want one of them to have red hair. So we say the probability of having red hair is 1. So that means that 3 of our children will not have red hair. So that's the probability of not having red hair. When we put this in our calculator, let's see, 4 choose 1 has a value of 4, so it's going to be 4 times, well, 1/4 raised to the first power is 1 over 4. 3/4 raised to the third power is 27 over 64. And if you want, you can throw that in your calculator, or remember that this reduces with this, leaving me with a probability of 27 out of 64. If the log base x plus 1 equals 64 equals 3, find the value of x. So this is, we're going to map it out. Base raised to the answer equals the power. So the base is x plus 1 raised to the answer of 3 equals the power of 64. So if you're looking at this, one thing you might want to do is x plus 1 to the third power would mean x plus 1 times x plus 1 times x plus 1. That seems very, very tedious. So I'm going to pause on that thought. And what else could I do here? Well, I want to get rid of this power of 3. So I know if I take the cube root of this side, I'll have to take the cube root of this side. Something raised to the third power, but taking the cube root of that cancels each other out. So x plus 1 equals, so on my calculator, if I go to math, choice 4, I'm going to take the cube root of 64, and I get a nice value of 4. All right, so I'm going to continue to solve for x, minus 1 to both sides, x equals 3. Factor completely. So whenever it says factor completely, it should trigger you to know that there's not just going to be one factoring technique used. You might have to use several over and over again. So now this one has 4 terms, so I'm going to bypass looking for a GCF. I'm going to bypass asking if it's the difference of squares. I'm going to bypass saying is it a trinomial, and go right ahead and do factoring by grouping. So I'm going to group these two guys together first. The GCF of x to the third minus 6x squared is x squared. Right, when I continue factoring here, I get x minus 6. Now, I'm going to group these guys together, and I'm going to say the GCF of those guys is negative 25. And then it's going to be x minus 6. And we're happy because now they both, each term has a common factor of x minus 6. And I put my x squared minus 25 in a grouping symbol together. So now here is where the factor completely comes into play. X minus 6 is in factored form, but x squared minus 25 is the difference of squares and can be rewritten as x plus 5, x minus 5. Express x times I to the 8th minus yi to the 6th in simplest form. Well, if you ever panic on your calculator, you can hit math. You can go over here to number, and choice 3 says I part. Well, if I don't remember what I to the 8th is, and I remember my I part button, I to the 8th has a value of 1. If I forget what I to the 6th is, I can go to math, go over to number, go down to choice 3, I part. I'm going to hit I raised to the 6th has a value of negative 1. Or I can remember the values are I squared, I to the 3rd, I to the 4th, right? I equals I squared equals negative 1, I to the 3rd equals negative I to the 4th has a value of 1. So x to the 8th, well, that would go 1, 2, 3, 4, 5, 6, 7, 8 would have a value of 1. minus y, I to the sixth, 1, 2, 3, 4, 5, 6 has a value of negative 1. X times 1 is x, negative y times negative 1 is positive y. Number 34, given the equation 3x squared plus 2x plus k equals 0, state the sum and the product of the roots. Now, I know in my class we did not have the opportunity to go to this, so this is one of those ones that you would want to memorize. The sum is always equal to negative b over a, and the product is c over a. And we get the a, b, and c values by comparing it to the standard form of a quadratic, ax squared plus bx plus c. So in this case, a equals 3, b equals 2, and c equals k. So negative b over a would be negative 2 over 3, and the product would be the c value, which in this case is k, over 3. So those are your sum and your product of the roots. Number 35, determine which set of data given below has the stronger linear relationship between x and y. Justify your choice. So this is a calculator-based question. So you're going to want to hit the stat key. We're going to edit a list. I want to clear this out first. And in L1, I'm going to enter 1, 2, 3, 4, 5, 6. I'm going to do the same. And L2 is going to be my y values, 24, 30, 36, 51, 70, 86. Okay, so now that I have my data in there, I'm going to hit the stat key again, go over to calc. And because it said a strong linear relationship, we're going to go to choice 4, which is the linear regression. Hit enter again. Ooh, so if this happens during the exam, ask your proctor, your stat diagnostics are not turned on. So we're going to go to second catalog. We're going to arrow, it's going to take forever. When you get your calculator, it should, your stat diagnostics should be turned on, just like it should be in degree mode. But if you ever get something that you're not sure of, just ask the proctor for a new calculator, and hopefully a math teacher will be around to help you. So we're see diagnostics off, diagnostics on. I'm going to hit enter. Okay, so now I'm going to go back to my stat, calc, choice 4. I'm going to hit enter again. Ooh, let's say something happened here. Stat, calc, choice 4, hit enter. Hold on one moment, I'll be right back. All right, sorry about that. So if we look here, we're looking for the correlation coefficient, which is the R value. And so for set A, the correlation coefficient is the R value. So this one is R equals 0.976, and I'm just going to do it to 3 decimal spots. If you do it for set B, same steps. You're going to want to put your data into the L1 and L2. You're going to hit the same buttons again. So you'll have to trust me on this one. We get negative 0.994. I rounded to 3 decimal spots, and it says which one has the stronger linear relationship. I'm going to go with set B. Even though it's negative, we want the value, the R value, that is either closest to positive 1 or closer to negative 1. Set A is a positive relationship, where set B is a negative relationship, so this one has a negative slope. But this value here is closer to negative 1 than this value is to positive 1. All right, part 3, again, these are 4 credits each, so they might be a little bit more challenging. Find the measure of the smallest angle to the nearest degree of a triangle whose side measures 28, 47, and 34. So I like to draw a picture. So 28, 47, and 34. They want to find the smallest angle. So I know the smallest angle is across from the smallest side. This is my smallest side, so I'm looking for this angle. So now if we wanted to be clever about this, we've already used the law of sines. And if you were thinking that you wanted to use the law of sines for this, we're missing some information. I can't you apply the law of sines. I have to have at least an angle to use the law of sines. So we're going to go ahead and we're going to use the law of cosines. And remember, you don't have to memorize this. This is in your reference sheet. So I'm going to start with my side of 28, and I'm going to say 28 squared equals 34 squared plus 47 squared minus 2, 34, 47. Whoop, look at me using a sign. Cosine of, I'm going to just use C. So now, as I've said before, we're going to evaluate 28 squared. You get 784. I'm going to evaluate 34 squared plus 47 squared. I get this value, 3,365. I'm going to evaluate 2 times 34 times 47. I get 3,196. Sine of C. I'm going to continue to try to isolate the sine of C. I'm going to subtract this value. 784 minus 30,365 is negative 2,581. 3,196. Sine of C. Continuing to isolate the sine of C. I'll grab my calculator. So let's see. I want to do negative 2,581 divided by negative 3,196. I get this really long decimal, so that would be equivalent to the sine of C. So now in order just to find out what C is, what the degree measurement is, we're going to hit second, cosine, go up and grab that. Enter again, and it wants it to the nearest degree, so I'll go ahead and say that 36 degrees equals C. So again, that one was using the law of sines, where it's C squared equals A squared plus B squared minus 2AB cosine of C. Law of cosines. Solve algebraically for x. Well, when you're adding or subtracting fractions, hopefully you remember that you need a least common denominator. So in this case, my least common denominator is going to be x and x plus 2. So I notice this guy, this first fraction here, he needs an x plus 2. Whatever you do to the top, you have to also do to the bottom. The next fraction here has the x plus 2. It's missing the x, so I'm going to multiply top and bottom by x. And this last one, he's missing an x. So I'm going to rewrite it. And just double check myself to make sure that all of the denominators are the same. And if you notice, I just evaluated x times x is x squared. So now all the denominators are the same, and because this is an equation and they didn't ask us to simplify an expression, we kind of ignore the denominator. We could include it. It ends up being more algebra, and if you just trust me, the denominator can be temporarily eliminated, and I'm just going to work off of the numerator. Ooh, and I see that I have this x squared, so I know I'm going to have some kind of quadratic. I'm going to distribute. So I notice when I have a quadratic, I want to make sure that my quadratic term, the x squared, is positive and it's set equal to 0. So I'm going to have to add 2x to the other side. And I'm going to write it in standard form. So I have x squared plus 5x plus 6 equals 0. I'm going to go ahead and factor that. Two numbers that add to 5. Multiply to 6. Solve. So normally this is where I would tell you you have to check, and I'm still going to encourage you to check. But let's talk about this negative 2 here. If I replace it in this first fraction, I can have a negative 2 in the denominator. If I replace it in the second fraction, I would have negative 2 plus 2, which results in a 0. And we know when 0 is under the line, it's undefined, and that can't happen. So this one automatically gets omitted. It's an extraneous solution. Then I'm going to use my graphing calculator, and I'm going to check just to confirm that I didn't make any arithmetic errors that negative 3 is actually a solution. Negative 3 does work, so when you check it, it should work. 38. The table below shows the final exam scores for Mr. Spear's class last year. Find the population standard deviation based on these data to the nearest hundredth. All right, so again, you're going to need your graphing calculator. We're going to use the stat feature. We're going to edit a list. I'm going to go ahead and clear this data out of there. And you want to make sure the frequency is where I think students would most likely to get tripped up. So this is a 72, this is a 76, but this is a 79 4 times. This is an 83 5 times. Okay, so on and so forth. That's an 85 7 times. All right, so I'm going to enter all this data in my calculator. Okay, so you can see my data has all been entered. I double checked to make sure that I entered each test score in the appropriate number of times. So now you're going to hit your stat button. You're going to go over to calc. We want one variable stats. I'm going to hit enter. So if you look at this, the X bar means, what does the X bar mean? It means the average. Summation of X squared, S of X, and then standard deviation of X. It asked us for the population standard deviation. The SX is the sample standard deviation. So we are going to go with this value that looks like this. And if you look on your calculator, they asked the nearest hundredth, so that would be 5.17. And that answers that one. Determine the number of students whose score are within one population standard deviation of the mean. So we're going to go back to our calculator. The mean was 84.46. So I'm going to write that number right there. And we want one standard deviation below and one standard deviation above. So what I like to do is 84.46 plus the standard deviation value. That has a value of 89.63. And then I take the mean and then subtract it to get the one standard deviation below. And that is 79.29. So I want to know what test scores are between 79.29 and 89.63. Well, let's see, a score of 83 would fit in there. A score of 85 would fit in there. A score of 88 would fit in there. And if I notice from the chart, 83 happened 5 times, 85 happened 7 times, and 88 happened 5 times. So 5 plus 7 plus 5 is a total of 17. So there are 17 scores within one population standard deviation of the mean. Okay, here's the last one, 6 points. In the interval of when theta is between 0 and 360 degrees, well, it includes 0, doesn't include 360 degrees, solve the equation 5 cosine of theta equals 2 secant of theta minus 3 algebraically for all values of theta to the nearest tenth of a degree. All right, so let's see, what do we have going on here? Well, first, I'm going to put it to one side. I'm going to set all my values. I'm going to set it equal to 0 and see what I have going on there. Okay, well, oh, and that's a plus. Doesn't look very nice. I don't like that there's a cosine value and a secant value, so I'm going to get rid of the secant value by turning it into a cosine, right? Because secant is equivalent to 1 over cosine of theta plus 3. All right, so now we're making some progress. Now I need to get that cosine out of the denominator, so I can do that by multiplying the entire equation by cosine of theta on both sides. So now I'm going to have 5 cosine squared theta minus, this cosine will cancel with this cosine, plus 3 cosine of theta. And we know 0 times cosine of theta is just 0. Okay. Now I'm going to write it in standard form. 5 cosine squared theta plus 3 cosine theta minus 2 equals 0. I'm going to go ahead and use my U substitution. So wherever I see a cosine of theta, I'm going to replace it with u. So I have 5u squared plus 3u minus 2 equals 0. All right, now I'm going to move into the second phase here. Now I have to factor this. So I need two numbers that multiply to -10 and add to 3 at the same time. So I'll let you think about that for a second. Multiply to -10, add to 3. If you said 5 times -2, you are correct. So this is going to be 5u squared plus 5u minus 2u minus 2 equals 0. Again, there's 4 terms here, so I'm going to factor by grouping. I'm going to group these guys together first. Their GCF is 5u. It's going to be u plus 1. Then the next grouping together, I'm going to group these guys together. Their GCF is -2. It becomes u plus 1. I know I factored correctly because I have u plus 1 in a parenthesis in both terms. I group the 5u minus 2 in a separate parenthesis. So now I'm going to go ahead and remember that u isn't u. U is cosine of theta, and I'm going to do two things in one step. I'm going to replace u with cosine of theta and set it equal to 0 at the same time. So cosine of theta plus 1 equals 0, and 5 cosine of theta minus 2 equals 0. So I'm going to go ahead and solve for cosine of theta. Okay, now I want to just get theta. So a couple ways you can remember. You can go back to your unit circle, right? I have a 1, 0. I have a 0, 1. I have a -1, 0. 0, -1. Cosine is always the x term. So where does cosine have a value of -1? Let's see. So here's 0, 90 degrees, 180 degrees, 270 degrees. So cosine is -1, that would be 180 degrees. 2/5, that is not a nice one. So that one I'm going to actually need my calculator for. So I'm going to take my calculator, I'm going to hit clear. I'm going to hit second cosine of 2 divided by 5. Hit enter. I get 66 point, I'm going to have to go back and read the directions again. What did they ask us to round to? To the nearest tenth of a degree. Okay, so 66.4 degrees. Okay, so cosine is positive. So that's this angle right here. This is the 66.4 degree angle. So now I got to do some thinking. Where else is cosine positive? Well, in the second quadrant, cosine is negative, right? Because that's a negative x distance. In the third quadrant, that's also a negative x distance. So that means that I have another cosine that's positive in this quadrant. And if I want a 66.4 degree reference angle there, I'm going to use the knowledge that this is 360 degrees. That is 66.4 degrees below it. 360 minus 66.4 is 293.6 degrees. So your answers are 180, 66.4 degrees, and 293.6 degrees. They are all within that interval, so we know we did it correct. So sometimes you got to be careful with these. Usually if it's a non-zero, 1, or -1 answer, there are 2 possible solutions. So just be careful when you do these. All right, well, thanks for tuning in. I wish you guys the best of luck. Remember, the exam is Friday, June 17th. The exam starts at 8 a.m., so I encourage you to get to school prior to 8 a.m. so that you are ready to go, eat a good breakfast, and hopefully we have some wonderful news to share with you, and then everybody passes. Thanks for tuning in. Have a great night.